Namaste, welcome back to my channel. Today we are going to discuss about something called competency-based questions actually. So as you know, since from last 2 years, CBSE board is examining, CBSE board is increasing the competency-based questions in the examination. So this is because to increase the analytical thinking of the children's actually. See, actually what happening? Children are studying well in the up to 10th levels because they are memorizing the answers and they will as we can say mug up the answers and they are going to vomit in the examination and all. This is going to happen unfortunately when they are writing the competitive exams like JEE or else NEET exam or other competitive exams. They are lagging there. So to fill this gap actually CBSE plan to increase the competency based questions, and these are the questions which are designed to check your ability. It will check your ability how you are going to apply the concept in the real life scenarios. Okay, means how you are going to solve the problems by knowing the knowledge of the concept and all. So that this seems why, because when we will go for the job interviews and all, so these all things will becomes very very important. So that's why today let me discuss what you mean by the competence based questions and how the questions looks. Okay, so let me explain now. Okay, now so there is a question. Okay, now see, suppose if they given the question that 1 mole of HCl react with 1 mole of sodium carbonate. Okay, so what it forms, they're asking to write the balanced chemical equation. Write the balanced chemical equation. So generally what we know actually, we know it will be an acid and it will be an metal carbonate. Generally what we will write that HCl plus sodium carbonate, it forms NaCl salt and H2 and CO2 gas. And this is equation something which is right when you're balancing. So let me balance first. Okay, so just let me explain. See here, how many hydrogens are there? Two hydrogens. This side, how many are there? So only one hydrogen. That's why I multiplied HCl with a 2. Okay, so that hydrogen can be balanced. And 2 into chlorine, 2 chlorines are there. Here I should balance the chlorine. So I'm multiplying NaCl with a 2. Now hydrogen balance, the chlorine balance, come to sodium. Two sodiums are there. Anyhow, already we multiplied with the two. It's balanced. One carbon, and there is an three oxygens are there. Three oxygens. So now it is balanced. You see, this is the equation what we are learning. HCl reacting with the sodium carbonate, it gives salt, hydrogen, salt, water, and carbon dioxide. If they ask the question, write the balanced chemical equation for the reaction between HCl, I mean dilute hydrochloric acid, with an sodium carbonate, then we can write this equation. Okay. Or else if they asked, write the balanced chemical equation when the dilute acid is going to react with an metal carbonate. So that's also correct, the way of asking question. But in this question, you see they are asking, write the balanced chemical equation when the 1 mole is reacting. So 1 mole means what, sir? 1 mole. This place will be there. No, before the every compound there is a place that is called a coefficient place, and this coefficient place represent number of moles, number of molecules, and all volumes and all. That's why you try to think here. Here the question is asked about the if the 1 mole of HCl is reacted. So let me write here HCl, okay, and Na2CO3, Na2CO3, okay. Now see here, try to understand. To form H2O, we require 2 moles of what you call HCl. But here, how many moles are there? 1 mole. That's why what happened? Just one night. You know very well. This is an acid, right? This is an acid, and this will be. We can say this will be an basic salt, sodium carbonate. Okay, sodium carbonate. Now we can say hydrogen. One hydrogen can replace only one sodium. As a result, what happens? It forms sodium hydrogen carbonate and NaCl. So we are not getting water and carbon dioxide. That's why I should think there. 1 mole means this will be the, because here partial neutralization is taking place here. This is basic salt and they are using the acid actually. This is partial neutralization is taking place. That you should understand here. Okay. So what I'm saying, In this reaction, you see, in this reaction, so try to understand. In this reaction, one hydrogen is replacing one sodium, and one more sodium left remains there only. So we'll get sodium hydrogen carbonate and NaCl. And so they ask sub question B also. They're asking what happens to the litmus paper if in this reaction mixture. In this reaction mixture, if you are keeping litmus paper, you think like there is an if you think beaker, okay, and I have reaction mixture here. I have a reaction mixture, okay, reaction mixture. It means it contain sodium hydrogen carbonate solution. It contain sodium chloride solution. Okay, na? Now in this case, if you are keeping the blue litmus paper, what happens blue litmus paper? To try to understand. See, blue litmus paper will be remains blue because you see this is on base, and whatever as amount of acid we added, no, that will is not sufficient to neutralize. That's why we got different products here, right? That's why this is not called complete neutralization, and remaining thing will be what remains base remains here. That's why blue remains blue only. There is no change in the blue paper. If I kept a red paper, suppose you think like I'm keeping a red litmus paper. I'm keeping a red litmus paper. What happens? If I'm keeping red litmus paper again turns into blue color. Why? Because it's a basic, right? So what you can say? Red red paper turns into what we can say blue because solution is basic in solution. So in this way, you should think about this competency based questions. General equation we know very well, and when you're writing balancing, you will write. But what they asked here, they asked 1 mole of HCl. Okay, now let me take one more example. Now see one more example is it. Now come now you know very well about double displacement reaction, right? This question is about double displacement reactions here. CuCl2 Cu, just a second, just second. Now see CuCl2 reacting with a sodium sulfate Na2SO4. Okay, aqueous solution copper chloride reacting with aqueous solution of Na2SO4. Now what are the product? Before that you try to understand. Barium chloride we have BaCl2 react with a sodium sulfate. Okay, aqueous solution. And this one, can you say this one is double displacement reaction or not? Yes, definitely you can say. Barium will form barium plus 2, and chlorine will form chlorine minus, and sodium will plus sodium plus 1, sulfate will be minus 2. Okay, now we know very well barium will replace the sodium, and sodium will replace the barium. Okay, now we can say result will be an BaSO4 plus NaCl. Okay, here there is a confirmation that this barium sulfate is an insoluble solid. Barium sulfate is insoluble, insoluble precipitate, they can call precipitate. Okay, precipitate means insoluble solid. So I can confirm this is insoluble. It means that if I taken the test tube, if I taken the test tube, in test tube at the bottom, okay, at the bottom you can say white color insoluble substance. I can say this will be an BaSO4. So that I can say this reaction is a double displacement reaction, right? Now when you are taking these two, you try to understand. You please try to understand here. This is not a double displacement reaction. Why I will say now? Now see, Cu will form Cu plus 2 ions, and Cl will form Cl minus ion. Sodium will form sodium plus ion. Sulfate will form sulfate minus 2 ions. If I taken the reaction mixture, if I taken the reaction mixture, they remain same only. They remains same only. It means Cu will present as Cu plus 2. Cl will form Cl minus, and sodium will form sodium plus, and sulfate is forming sulfate minus. These we don't know which is going to combine with which one. Either Cu plus 2 may combine with a Cl, or it can combine with a sodium. So not sodium, you can say sulfate. Sodium can combine with a Cl, or you can combine with a sulfate. We don't know which one is going to combine with which one, because they are available as ions, because both they are not at all forming CuSO4. They are not forming what we can say NaCl. How we can say? Because there is no proof at all. If I want to say it's a chemical chain. There should be a change in the color that is going to form. No. Why? Because copper chloride is also blue to green color. Result the copper sulfate also blue to green color only. Now see NaCl is a colorless. NaCl is colorless. NaCl is also colorless. We can't say change in color. No. Okay. The formation precipitation here. No. There is no chance at all, because this is also an soluble salt. This is also an soluble salt. Understanding. Okay, that's why what we can say, this is not categorized as a double displacement reaction. So try to understand here, when you are studying about double displacement reaction, at any cost, okay, at any cost, see, when we are discussing about double displacement reaction, at any cost, salt water, which we are calling as neutralization reaction, takes neutralization reaction. I'm saying again, whenever we are studying about double displacement reaction, so what we are saying here, double displacement reaction is a reaction in which there is an exchange of ions between two salt solutions. Exchange means what? After exchange, when we are saying there is an exchange of ion, actually, suppose you think like, suppose if I'm using, if I'm saying, uh, suppose if I'm saying here, I'm saying when I'm saying exchanging, you see barium is barium chloride is exchanging barium ion with a sodium sulfate. So sodium sulfate is exchanging sodium ion with an barium chloride. So that barium sulfate is formed. So that NaCl is formed. What about here? Here, when we are dissolving, when we are keeping these two salts in the water, they are available in the form of ions. Okay. There is no confirmation that copper is combining with the sulfate. There is no confirmation for sodium is combining with the chlorine only. It may be, and sodium may combine with the sulfate also. Sodium may combine with an chloride ions also. There is an two possibilities for the sodium. Same way, copper also can combine with a chloride ion, or it may combine with a sulfate ion. That's why we can't confirm copper sulfate is formed or copper chloride is formed, sodium chloride is formed or sodium sulfate is formed. That's why this is not categorized as a double displacement reaction. So that's why we should be careful whenever we are attempting the question in the CBSE board exam. Okay, be cautious about questions. Okay, then how we can understand the question actually? So let me explain one example here. Suppose we have a this concept. Okay, we have this concept. See, try to understand here. There is a concept called how do acids and how do acids and bases will react. So let me read activity here. See here, in this activity, what they given. See here, they are saying take about 5 ml of dilute, 5 ml of dilute sulfuric acid. They are asking to take 5 ml of dilute sulfuric acid. Okay, and add the zinc. They are asking. Okay, we have equation Zn react with an sulfuric acid. It forms ZnSO4 and hydrogen gas. So we know very well this is an metal react with an acid, it forms salt and hydrogen gas. Okay. Now what you observed on the surface of the zinc means, you can see the diagram here. They given the diagram here. Upon surface of zinc, there is a production of hydrogen gas actually. Okay, now hydrogen gas is liberated. So we can write hydrogen H2 gas is H2 gas is produced here. Okay. Now see, pass the gas being an evolved in the through the soap solution. So what happens here? So when they are passing the when they are when they're passing this hydrogen gas to soap solution is used to trap the hydrogen gas. Why? Because this hydrogen gas will be there. No, it will be an insoluble in the water, That's why to trap that soap solution, they are supposed to use the that's why to trap the hydrogen gas, they will use the soap solution. Okay, so later they will bring the glowing candle near to it, and it is going to burns with an pop sound. If pop sound is produced, means we can say there is an production of hydrogen gas. Okay, na? So this is not a problem with us, because it is explained in the it is given in the activity. Now see, they're asking repeat the activity, repeat the activity acids like HCl, HNO3, and CH3COH. Now see what happens, and they're asking to observe. They're asking to observe whether observations are same or different. Okay, let me explain. Let me explain here. Okay. Now see when they are saying, just a second. Okay. See when they are saying about they're asking repeat the activity with HCl. Let me take first H2SO4. If I take an H2SO4, you know very well, 1 mole of zinc will react with 1 mole of sulfuric acid. It forms 1 mole of ZnSO4 and forms hydrogen gas. Okay, hydrogen gas. Now, if I take an same zinc with an HCl, it forms ZnCl2 plus hydrogen gas. Similarly, if I take an Zn plus HNO3, what happens in this case? In this case, hydrogen gas will not produce because it will act like a oxidizing agent. It forms ZnNO3. Okay, NO3 taken twice plus actually at the beginning hydrogen gas will be produced. Hydrogen gas will be produced, and later this is oxidized by the this is oxidized by the this is oxidized by this nitric acid. It converted into, it will give one oxygen, it forms into H2O. Instead of hydrogen, we'll get a water plus some other gas like NO2 gas or N2O gas or NO gas. Okay, now if I take an example of another example, Zn plus CH3COOH. Why they given this one? So let me explain. CH3COOH taken twice, Zn and hydrogen gas. You try to understand. Here you should think about two things actually. One is rate of formation of bubbles. One is rate of formation of bubbles. Now see, sulfuric acid is a strong acid. What about hydrogen gas formations? Are rate of formation of bubbles means the speed of hydrogen gas. See how much speed, how much fastly hydrogen gas is produced in case of sulfuric acid. Same speed only hydrogen gas will produce in case of HCl. What about in this case, sir? In this case, hydrogen gas only not produced. Okay. Now come to this case. What about this acetic acid? CH3COH means acetic acid. It's an weak acid, right? That's why rate of formation of hydrogen gas bubbles will be on here. You can say lower than what we can say H2SO4. This will be what we can say same like H2SO4, same like H2SO4. I am talking about how much speed hydrogen gas will be produced, how much fast hydrogen bubbles are produced. This is one case. This is another. So let me explain about another case. Now again you can rewrite the equation. See here, you can see zinc plus H2SO4. Zinc plus H2SO4 gives rise to ZnSO4 plus hydrogen gas. Okay, now one more is zinc plus one we can say HCl, it forms ZnCl2 plus hydrogen gas. Similarly, if I take an zinc plus CH3COOH, it forms Zn it forms CH3COO taken twice Zn plus hydrogen gas. Now here what is the problem? Again, why I have written one more time equation. You see here, now let me think about what about amount of hydrogen gas. Amount of hydrogen gas. You see, 1 mole of zinc is required, 1 mole of H2SO4 to produce what we can say 1 mole of an acid can produce hydrogen gas. How much? 1 mole. This case H2SO4. In case you can see we require 2 moles here. It should balance. To know that one, it should balance. Okay, you can see 2 moles of acid produces only 1 mole. Similarly, same case here also. 2 moles of CH3COH will produce 1 mole. It means when come to the amount, 2 moles of HCl is required to produce 1 mole of hydrogen gas. 2 moles of CH3COH is required to produce 1 mole of hydrogen. This is also should think. What may be one more way of asking question? They can change here. Now in this activity they change the acids, right? There is chance of changing metal also. So they can ask the question, if zinc is replaced by the copper, what happens? Hydrogen gas will be not at all produced, because copper is less reactive than the hydrogen. You should think one more thing here. When reaction is possible, we are taking zinc and you are comparing with what? Hydrogen gas, which is produced, which is there in the acid, right? H plus ions are there. If suppose this hydrogen gas is, suppose zinc is less reactive than the hydrogen gas, in that cases hydrogen gas will be not produced. Okay, na? So same way, if they given about in the place of zinc, if they given about magnesium, what happens? Maybe rate of formation bubbles will be faster, because magnesium is more reactive than the zinc. Okay, na? That may be the way of question. See, let me explain once again. So these all are the which is called competency based questions and all. So if you're feeling difficulty, or else you would like to get the more marks by in case of competency based questions and all, please follow me in the YouTube, so that this year I'm planning to make the videos activity wise, the explanation, in detail explanation, and what will be the way of asking question, and what are the previous year questions already asked upon the topic and all. So let me explain in details and all. So I hope so you understood the concept today what I explained. If you found the video, please subscribe, share, and comment in the comment section. Thank you for watching. Thank you all.